Hi, everyone. My name is Stephen Kilger. I'm the managing editor for Feed and Grain Magazine and the host of the Feed and Grain podcast. Thank you so much for joining me today as we dive deep into the issues affecting the feed manufacturing, grain handling, and allied industries. Today's episode is brought to you by the Bin Whip from Newmat Systems. The powerful dual impact Bin Whip removes the toughest buildup and blockages in industrial storage silos without hazardous silo entry. Learn more today at binwhip.com. For today's episode, my guest is Brady Galswick, co-president and second-generation owner of Easy Automation. We're talking about micro-ingredient systems, from how they improve feed mill efficiency, how big they can get when they aren't the best option for an ingredient, and the new technology that can make them even more accurate and save employees time. I hope you enjoy the interview. I really enjoy talking to Brady, and if you want to help out the podcast and are listening to this in a podcasting app, please rate us and subscribe. If you're listening online, sign up for the Feed and Grain newsletter, Industry Watch. Now, on to the show. Hi, Brady. Thanks for joining me today. Can you tell me a little bit more about yourself and what you do for the industry?
You bet. Well, thanks, Stephen, for allowing us to join. A little bit of background about myself. My name is Brady Galswick, co-president here at Easy Automation, as well as a part of the second generation, originally started by my father. So been involved in the industry through our family for many years, and our focus is around feed mill and agronomy automation, specifically feed mill equipment.
I always forget that you're a second generation. I feel like I need to get you and some other guys on just for that conversation. What's it like to grow up in this industry? Because it's got to be a unique experience, especially looking at it from someone like me who's came into it out of college and never did anything with it. Well, we're here today to talk about what is a microingredient system and how does it work at a typical feed mill.
Yeah, so a microingredient system is essentially to be adding those smaller inclusion amounts, which typically focus on the vitamins, the minerals, potentially the medications as well, that get added as part of the feed mill ration out of microsystem. Most commonly, the feed mill would be adding those by hand adds, so weighing each individual ingredient out by hand. So by implementing a microingredient system, there's a lot of benefits that we can expand on. But, the first one, of course, is not the need for that labor and having to sit there and weigh out each one of those ingredients over and over again.
Yeah, well, it seems like in the old days, feed mixing used to kind of have more feeling to it. Now it's much more of a science, right? Like there are definitive things that you need in certain amounts for any recipe you're doing. So how do these systems kind of like ensure that accuracy and consistency in a way that even a hand batching system wouldn't do?
Yeah, so as you mentioned, it's kind of interesting that in some ways we have so much of the mill automated. Sometimes this hand add part of the mill isn't as automated, but actually, even though these ingredients have a small inclusion rate, so it doesn't seem like you're adding very much, those can actually be some of the most expensive ingredients for the total ration and the ones that need to be the most precise for both a pricing or costing standpoint, but even more importantly, to make sure it is matching up with what that formula called for, why the nutritionist put that into the formula, and ensuring that the animals then perform to their peak. Even just little changes in not putting the right amount can have a huge impact as compared to maybe some of those other main ingredients, which are more commonly even automated, that just really emphasizes the importance of automating in a microingredient system. So how it does that a little bit is what it's doing is it's weighing out each individual ingredient. So the benefit of that is that then it implements the automation where it is weighing out that ingredient, saying how much it called for, the exact precise amount that it was added, and then being very precise in the amount that was added. And then the full traceability of that, where for a hand add system, it was actually implemented ways to improve the accuracy and traceability of that as well. But by being able to look back and see exactly how much was weighed out, really just gives a lot of confidence to the mill and ultimately the producer or the animal owner that feed was produced in a way that was requested and very accurate.
Yeah, and it gets that consistency in product, right? You want your customers to be able to know that they're buying the exact same formula that they bought last time. Not any differences, no changes, no one guy accidentally does another scoop of calcium in there by accident. Messes the whole thing up. If I'm a feed mill manager and I am looking to either invest in a micro ingredient system for my current mill or I'm building a new one, what are some of those factors that they should really be considering when selecting a micro ingredient system, because they come in all kinds of, well, they all look roughly the same, but they come in many different sizes and shapes, right?
Micro ingredient systems can come all different sizes and shapes, and you can kind of ask why all these different ones, but they each have their specific application, or I should say specific range, as well as price points. Some are more economically made for that smaller feed milk. It's still important that they have a microsystem. They just don't put as many tons through that. So therefore they're looking for a little more economic, and then medium, and then all the way up to very complex, very sophisticated microingredient systems that very same equipment and technology could be utilized in human food consumption or pet food consumption or the like. So it just has a wide range of types and those kind of finishes, the type of hardware that's provided. But first thing they do when we're considering a microingredient system is basically to look at what are the ingredients that you're putting in by a hand edge or that type of inclusion, and which ones make most sense to replace with a microingredient system. This really can depend on the type of feed mill that it is. So like a commercial mill where you maybe have a wide range of species, a wide range of customers, and everybody has a little bit different variation or different types of ingredients they want to put in hand ads. Quite frankly, it might never make sense to have a micro bin for absolutely every single type of ingredient they could throw at you. So what you do there is then maybe look at the most common, that 80-20 rule, right? What is going to have the most bang for its buck, and what are those ingredients that get put in almost every batch or on a consistency, and identify those and allocate that. It's much more straightforward if you're an integrator where you're producing the same type of feed for a specific species, that your choice of hand ads and those type of ingredients is just going to be much more limited. So therefore, it's just going to make even that much more sense and likely not need as many bins. From there, we usually look at, I have people give me example formulas, or we look at some of the most common formulas. What are those inclusion rates of those specific ingredients? Total batch. How big is your mixer? So how much not only are we putting in of each ingredient, and calculating the right amount of scales and how to spread over the right amount of scales to hit your correct batching times, but also from a capacity standpoint, right? Some formulas may only need 20 pounds of this ingredient. Some formulas, where if it's a premix, might need 150 pounds of this ingredient. We need to set that microsystem up to be able to handle both of those. And so that might look like a different type of micro, a different type of scaling system. It all just really depends on the specific application.
And that makes a lot of sense. Some facilities out there have dozens and dozens of formulas with really small ingredient needs for depending on what stage of the animal they're in and all that jazz, which is a completely different topic. But there's also hand ad stations that, they weigh the product to make all that more accurate. So even if you're having to add some of those ingredients yourselves, it's not like the old days where you just kind of guess based on the measurement. It's all that can be automated, even your hand adding stuff.
Correct. I mean, just for some general rules of thumb that we look at, if you're an integrator, if you're on the poultry side of things, more commonly you're maybe having that 8 bins to 16 bin micro. If on the swine side of things, maybe more like that 16 to 20 bin micro. Again, on the commercial side, just what makes the most sense for your application, how much hand edge you're trying to eliminate. We've done several systems. One of the largest was 2 microsystems, each with 40 bins. So the total of 80 bins on that. And then they actually had a 12 bin loss and weight system as well. So close to 100 different, over 90, but close to 100 different ingredients through some type of microsystem, and different ones allocated different systems depending on the inclusion rates and requirements around each.
And you mentioned that sometimes, depending on what ingredients you need to have in the formulation, might change how you want the system designed. Does it involve how much they stick and all that kind of stuff? Does all that go into the calculation of what you need?
Going to different types, as well as a lot of it's based on the total batch size and how much capacity we're going to need. One specific difference is when we're looking at those very, very expensive or precise ingredients, such as medications, where not only does it have to be very precise in how much they put in, but also we're going to want to reconcile that inventory at the end of the runs and want to have the weight of the individual bin. That's a great fit for a loss in weight type system, because it's able to dispense it out, be able to be very accurate, do multiple bins simultaneously. And a great application for that is actually dispensing directly into a mixer. While our gain in weight, what happens is it comes out of the micro bin into some type of scale, then that gets dropped into a conveyor to the mixer. So that's very common and it's most economical for most ingredients. But there are some transfer points along that way for the potential for contamination from medication or a loss in weight system. We can put them just directly over the mixer and truly into the same hole that the hand ed would be getting dropped into. So there's no chance for contamination between batches.
So, what are the common challenges you find people having when they are thinking about kind of adding one to either an existing mill or even building around it? What are some of the challenges you find people run into when they're implementing this kind of system into their feed processing?
Well, no doubt with an existing mill, the hardest challenge is space constraints because everybody thinks they build their mill big enough, and just like a house or a garage, right, you fill up that space. So finding the space for a microingredient system in an existing mill is one of the biggest challenges. So you have to have the space for the micro itself. Then you have to also think about how is the forklift going to access it or access the platform in order to get close enough to drop those bags off to then dump into the microsystem, as well as then from a conveyance standpoint. So from the microsystem to the mixer, how is conveyor going to be through there? The more horizontal and the shorter the distance that is transferred, the better. That just decreases the risk of contamination. Now, in saying that, we've designed our systems to be very flexible in order to give us the most amount of different variations to fix it in. So maybe that's putting all the bins on one side. We have also the ability to have either very large bins, medium-sized bins, or very small bins where you can fit two bins essentially into the same footprint as just one. The benefit of that is maybe you don't have a lot of space. And even though it'd be nice to have more storage, you only can fit in this space. So we can custom design the system to fit in that space, as well as work with the millwright or end customer in coming on site, doing the measurements, laying it out, helping to figure out how to route the conveyor. And sometimes just an outside perspective is really great. It's a little bit like, sometimes you kind of get used to looking at your house a certain way and you think it would be good to have it one way. Well, we're able to come on site, work with the customer, maybe bring a couple different opinions or options to them, how we could do it, and then come back, draw it up, and be able to see those in 3D format to really get a handle of how this would fit, how this would flow.
And that's good to hear, because I always hate when new technology, to implement it, people need to build a whole new mill, because that's just not realistic for most people. And all feed mills should be able to benefit from the newest improvements in these things if they can. So it's nice to see you being able to come out and, because you're the knowledgeable one too, so you know what'll fit.
Another kind of common thing that we're seeing these days is there's the concept of going from no microsystem to a microsystem. We also see variations from there. So there's also, maybe they have an older microsystem where they just had all their bins or all their ingredients, say 20, 24, 30, all on one scale. Well, the problem is if it's on one scale, if it's a gain and weight system, it can only weigh up one ingredient at a time. So they said, hey, we've increased our mixer size or we've sped up our capacity. We need to weigh up these micro ingredients faster. So what I've done actually in several mills, I've taken that same footprint that older style micro system was in, split that up into two different scales. So half of the bins were on one scale, half on another, and potentially, again, because they're utilizing more ingredients, they're pushing more through the mill, also implementing a tote system where we can unload bulk bags as part of it as well. So they can even split that what was one scale over to really two micro ingredient scales in a tote system. So therefore, you're essentially triple the speed of that weigh up, as well as on the tote system for those very highest inclusion rates, not having to handle all those 50-pound bags, but instead do it with a forklift in full 2,000-pound bags. I've seen mills where that was the choke point enough that by doing that increased their production of their entire mill between 20 and 30% because it was just waiting on those micros.
And if you can use kind of a bulk bag system, why not? Can't be fun hauling over those 50-pound type bags and unloading them in.
Absolutely. I mean, we see benefits on the tote system between handling the bags, getting them from the supplier, any potential liability issues of lifting those bags and stuff. It just much smoother to not have to. I mean, each bulk bag is literally 40, 50 pound bags, right? So it's a significant savings. As well as when you're talking about those larger inclusion rates, it is a good fit because they can actually auger them out or feed them out at a faster rate with larger augers than a microsystem would have.
Yeah, and you don't have to do it so often, which would be very nice. One of the things that I mean, they look micro ingredients, they look complicated, right? It's a bunch of smaller bins that go out into one thing. What is the maintenance like on a system like this? Is it, how often do people have to maintain it? How do you make sure it's functioning properly?
In a lot of ways, they are pretty low maintenance. There is definitely moving parts on them, but it is relatively low maintenance. Just generally checking it out, visually inspecting it. Again, depending on the type of scaling system, gaining weight scale system, it can be good to open those access covers every once in a while and visually inspect to make sure you're not getting any buildup or carryover contamination. Again, these ingredients that go through those microsystems are so often the most hard to handle ingredients in a mill. So they're the sticky ingredients or the dusty ingredients, and they can build up with not. So it's good to have a little bit of maintenance to ensure that that tub is getting cleaned out properly, or that any funnel scale is cleaning out properly, any butterfly valves are closing properly, and just the overall, also on the exterior side of things, right? If you're not taking care of it and the exterior of it's getting dusty or dirty, they could potentially contaminate and just not last as long. We also even have ability to help prevent that on the front end by having systems that have a vacuum system on the lid, so that when you open the lid and dumping the bag in there, it actually is sucking or vacuum any of that dust and debris out of there. So not only is it better for the individual dumping the bag in, but it's just better from a general maintenance point of view. And the other big thing is around the calibration and the load cells, right? Again, these ingredients are very specific inclusion rates, and the microsystem can only be as accurate as the load cells and calibration allow it to be. So having your scales regularly calibrated, regularly checked is important to ensure that it's truly getting the accuracy that it can have.
Yeah, definitely. And well, these always seem like they're very labor intensive, and they take a lot of time, to hand add ingredients like this, right? To change a formulation, and being able to automate all that seems like it would be a really big boost to me in how quickly you could get a feed made. I mean, you mentioned earlier, upwards of 30% more efficiency just from this bottleneck. That seems huge to me. How can these systems contribute to efficient feed production, especially in a day and age where labor is tight, it's less people, you're trying to get more done with less in general?
So when I go in a mill, most labor intensive areas would be around bagging system, as well as actually the filling of the finished product on the back end. The other one is this hand adds, or weighing out these micro ingredients. As you mentioned, labor is such a difficult thing to come by these days. Weighing out these ingredients one after another, day after day, is a very labor intensive job with, as I said, potentially some dusty type materials that you're working with. Not only that, well, it's very repetitive. It'd be a long day weighing these out over and over again. You have to be very careful on what you're doing, because it needs to be so precise and so accurate that it's hard to find that individual that wants to do this day in and day out and does a really good job of it and stays at it. A microingredient system doesn't need to take the breaks. It doesn't not show up for work. It doesn't try to get in a rush on Friday. It's just that dependability. It's one of the most common areas, if they don't have one, to either get one or to add more micro bins to help decrease the labor in this area and allow those people to focus on more of a value added area in the mill.
Especially because, unlike humans, it doesn't make mistakes. I don't care who you are. Weighing out ingredients all day, every day, you're going to eventually get distracted and you're going to make some mistakes. It's just human nature, right? Those aren't the tasks that we're good at. That's why automation exists.
So there's the concept of getting it right on the front end. But the huge value is also just the data collection and the recording of what actually happened in the back end. So from like a liability standpoint, right? So if a feed mill gets a call from a customer, they have a complaint that their feed wasn't made right, or they had a problem with the health of their animals, they're able to go back and truly say, this is what the automation said, here's how accurate it is, here's record time after time. Nope, it did the job it said it was going to do, as compared to trusting that somebody measured it out right. That lack of clarity creates more questions, creates less trust in the whole process, right? So that automation, and specifically a microsystem, helps build that level of trust for the customer that they truly are getting what they order.
Everyone hates to hear it, but We are entering a day and age where you need more and more backups. You need records. You need paperwork showing everything you've done. And anytime you can take that paperwork away from an individual to have to do and have it automatically filled in the back end, that's all the better, right? Are there any like emerging trends or developments in microingredient systems? What's on the cutting edge? What are you looking forward to?
So I would say that some of the emerging trends and developments of microingredient systems is, okay, now we've taken the hand add aspect away from the individual, so we have it more accurate, as well as they're not having to weigh out these ingredients all day, every day. However, there's still a couple opportunities where there is a potential for human error, and so we as manufacturers are trying to take those out. You have all these micro bins and they all have labels and whatnot, but the concept of a new person would open the wrong bin and dump the wrong ingredient in the wrong bin. The system thinks it has the correct ingredient and keeps weighing that ingredient out. So what we've implemented now is magnetic locking lids. So the actual lids of the microsystem are magnetically locked and each ingredient is given a barcode. So where it scans the bag to say this is the correct ingredient. This is X ingredient. Then you scan the bin you're going to put it on, and it actually releases it and opens it up, like kind of like if you go to a area where it opens the proper door, it allows it to put it in, so it only can put it in the proper bin for that ingredient. So that's a big area of trend. Another one is we're seeing more and more of what we call our dust-free lid or our vacuum lid, as I touched on earlier. Now the amount of labor that's being needed is just to dump the bag into the bin. So how can we take away that dust, take away that mess, and just overall really help with the cleanliness and appearance of the mill, as well as any potential for cross-contamination. Again, especially when you're thinking drugs or some type of ingredient that would kill one species where it's good for another, and how to prevent that. So those are two areas that we're seeing the most developments. The other ones is just, continuing to further refine on how accurate these systems can get and how precise they can get.
I imagine that's got to be an uncomfortable conversation if you accidentally have an ingredient in a long species and it ends up, killing some. That's not a fun lawsuit to eventually deal with. So I imagine those must be nice. Well, thank you so much for sitting down and talking with me today. I really appreciate it.
Yeah, I appreciate the opportunity to touch base on this. As I mentioned, microsystems is just one of the main areas of opportunity for automation and new equipment to decrease the amount of labor, increase the efficiency of the mill, and increase the level of tracking and traceability. So, these are the key things that mills are trying to do these days, and microingredient system is usually to the top of that list if you don't already have one.
And I'm sure if any listeners out there have questions, you would be happy to answer them at Easy Automation, which we will have all your website and everything linked in the description of this podcast. So go check them out, and thank everyone out there for listening. Have a great rest of your week and stay safe out there.